Yeah, so please close the door, please. Good morning, everyone. Hope you are all doing great today. Hope everybody is doing well. So I want to welcome you to our first proper class, the proper class of the KodeHauz online holiday tech camp. So officially, I'm welcoming every one of you, every single 16 people on this call. Yeah. So yesterday was opening stroke onboarding orientation session. You get. So today is where we actually begin our learning journey. Yeah, and I want to make something very clear from the beginning that this is not going to be one of those classes where I'll sit down and talk for 2 hours. No, that's not what this class is going to be about. This class is one of those classes whereby we're going to be asking questions. Like it's going to be so interactive. There'll be a lot of questions. There'll be a lot of educative videos attached, and we'll solve problems and build things together. So I don't want it to be like, please, I don't want it to be like I will just, put you guys on a call and then we'll be talking for 2 hours straight. Yeah, I want it to be very interactive. So if you are ready for the class, just say I am ready on the chat section. Just signify it, I'm ready. So I can know you are ready. Yes. That's the spirit. That's the spirit. Good, good, good. I like the vibes I'm getting. Yeah, so today's class we're going to be talking about let me share my slide. Please confirm if you can see the screen. So the question here is, how does technology think? How does technology think? It's a very oh okay. Before I start, sorry. Before I start, I would like to recognize a co-host in this call. He's going to be my assistant for this call. So he's part of the team. For Woody, please, for Woody, if you can say one or two words to welcome yourself. Just turn on your mic and say something.
Okay, good evening, everyone. My name is Fewabudi, and I'll be an assistant and a teacher during this class. Thank you.
All right. Thank you, Favor Woody. Thank you, Favor Woody. So, how does technology think? So, what do you think I mean by how does technology think? What do you guys think of that question? Like, what comes to your mind? Who can help me answer that question? How does technology think? Like, what comes to your mind when you hear the word technology and how it thinks? If you have an idea, please. Okay, I can see one hand. Oh, unmute you. Unmute. I can unmute your mic and let me have an idea. I can't hear you. Please, can you be more audible? Please, Charles, can you hear him? I can hear no audible, please. Um, maybe it should be a network problem.
I can't hear you.
Okay, let me ask the next person. Titoluwani, yeah, please unmute your mic and answer the question.
Good morning.
So,
Yes, yes, good morning. So what do you think? What do you think by that? What do you think from that?
okay, you are asking that I should answer how technology thinks.
Yes.
Okay, technology thinks based on what the user or the person that is using the computer tells the technology or the system to do.
Okay.
By wrong.
You are correct. You are correct. Nice one. Nice one. Who else has something to say? Who else has something to say, please? Please, I'll need all your ideas. No ideas a waste. You might actually have the right answer to say, but like maybe you're afraid or shy to say it. So I want everybody to be open. You know, I want everybody to. I need all your opinions.
Hello.
Okay, who does
Sorry,
unmuted the mic?
my mic was
Okay,
on mute. Sorry.
okay. So what do you think? Let's
So
hear
I
your
think
opinion.
technology, like how technology like develops and becomes better and benefiting to our world.
Yeah. Are you done? Please can you repeat? I didn't get
It's
you.
how technology becomes benefiting and helps our world in different ways. Like
Oh,
software engineering can make programs, can create the World Wide Web and do other important things.
okay, okay. You're not wrong. You're not wrong. You're not wrong. Nice one. Nice one. Thank you. So all of your answers are relevant. All of your answers are relevant. But by the end of this class, I want you to look at a phone, an ATM, a car, or robot, and start asking yourself, what information is this machine receiving, or what is it doing with that information, and what happens as a result? So, for those that didn't get the question, let me ask another question. So, let me ask, how much technology have you used today? Let's start with that one. I think that one is more interactive. Like, you woke up this morning, maybe you woke up this morning, maybe some of you have phones, you took your phones, maybe some of you have alarms, you get. So, what technologies have you used like all throughout this morning before like you came to this call? I would like to hear your, your so you can unmute your mic and just let's just hear the technologies you've used.
I don't really use much of technology in the morning.
Is it possible? Yeah.
Yeah, that is very possible. Like if you're dedicated to like make yourself better, I learned to like separate myself from technology, give myself like 2 hours of screen day a day.
Okay. Okay. No, but you need technology. When the tech world. So most of the times, you can't really achieve much without tech. Who else? I just want to hear like what have you used today? Maybe even your car is technology. So, the TV you use at home is technology. You get this laptop you are owning now is still technology. So we interact with technology every day of our lives. You get so you can't tell me that you've not interacted with technology like all throughout the day. Yeah, even right now we're using technology. You get so I need you all to like just let me know what technology you've interacted with today. I want to hear from you guys so that I can
I've
sure.
used I've used my phone and
Yes,
I've also used the blender and other technological devices.
good. Yes, that's good. That's good. Allow. So am I getting your name right? Allow, right?
Yes,
Okay. Okay. Yeah, nice one. Allow. Who else? I people
Sorry, sir.
shy. Eh?
Sorry, sir. I didn't get your question.
Okay. You didn't get the question. I said
Yes, sir.
how much of technology, or let me rephrase, how much of computers have you used throughout, like, this morning before you came to this call?
Okay,
Because
let's say from when the day broke, using of, let's say, alarm was not for everybody. Um,
okay,
everybody uses an alarm to wake up. Not everybody. And when you wake up, most of the times you use your phone or is any phone at all to check time.
yes,
And
yes.
some might have used computer, some might have watched TV and other things.
You just said an order, Mr. Michael. You didn't complete your sentence.
Okay, sir.
Yeah, but it's good. I understand. I understand. Nice one. Nice one.
Okay,
So,
sir.
yes. So by the end of this, I want you guys to understand that by the end of this class, I want you guys to really understand what computers are, and what tech is, because most of you self don't really know what this tech is. Some people are even afraid to see alarms because you think alarm is not a computer. You get, so I really want you to understand the concept of what a computer really is. You get, so before I actually, because I have a clip for you guys, I have a short clip that really explains what a computer is. But before I actually play that clip, I want to hear from you. What do you think a computer is? What do you really think is it refers to the word computer? Not the one you were taught in your schools, or not computer and electronic device, blah 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 blah. No, not that. This thing. You get. I want from your own understanding. What do you understand by the word computer
Okay,
in your own
a
understanding?
computer,
Yeah.
a computer is it's it's a tool that is used in
Okay.
everyday life. That exists in everyday life by a person to fulfill a task. That's the best way I can say it.
Okay. Okay. That's correct. That's correct. Who else? Please, you guys should not be quiet. So please don't be quiet. Let's not be like it's just one person that keeps giving um, feedback. If you're afraid to unmute your mic, you can still drop on the chat. We'll still see it. You get, so just on the chat, if you're afraid to unmute your mic, just let us know what you think computer is. Okay, I can see some hands. Um, flowers, right? Okay, yeah, flowers. Say something. Flowers, if that's your name, please unmute your mic. Okay. Please don't take your hands up and then when you're asked to unmute a mic, you cannot unmute your mic. Other people are actually waiting.
Okay. Yeah, that's really so from my
Good
okay.
morning.
From my own understanding, a computer, right, is any electronic device, your phone, your PC.
Okay. Computer is any electronic device, your phone, your PC. That means um your speaker is a computer because it's electronic. Yeah? She has not answered them. Okay. Yeah. I'll also be coming to the chat though, so if you are dropping, some other hands are up. Christian, let's hear you. Let's hear you. Let's hear what you think.
Good morning, sir.
Yeah, good morning. Good morning, Christian. So talk to me, Christian.
The answer is technology does not think that it follows rules.
Okay, which question are you answering? Sorry. Okay, are you answering this? How does technology think?
Yes, sir.
Okay. So how does technology think? Let me know.
I'm not hearing you.
Now I'm asking you, like, what do you what's the answer to the question?
Technology technology does not think. It follows rules.
Okay, it follows rules. Yes. You're absolutely correct. You're correct. It follows rules. True. But I was asking about computers. I was asking what a computer is. You get. Okay. Felicitas.
That's now within the mesh.
Good morning, everyone.
Yes, good morning.
I want to answer about computer.
Okay.
A computer is an electronic machine that
Okay.
access data and give us faster information.
Good. Nice one. Nice one. Clap yourself, eh? Yes, nice one. Nice one, Felicitas. I can. How about you? Yeah, very correct.
Computer is an electronic device that allows the user to type, create, edit, and save software on an app
So I didn't get. You said that does what? I didn't get you.
that allows users to create, edit, type, and make softwares on the World Wide Web,
Sorry. What is edit?
like to change things, to alter the original
Edit.
state of something.
Okay,
Yeah.
okay, 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 okay. You're correct. You're correct. Good. Nice one. Nice one, Gabriel. Okay, we have Andikan.
A computer is basically an electronic device which consists of software and hardware, in which the software tells the hardware what to do. So the
Good.
computer can be used for various activities like coding, gaming, uh, word editing, video editing, um, presentations, and so on.
Good. So you guys are all correct. You guys are all correct. There's no wrong person here. Yes, we're all saying the same thing. So I want you guys to understand that computer is what, like, we use computer in our everyday life. Yes. So I want you to really understand what a computer is. So I'll play this short clip. So before I play this clip, just take note of, there are four things to take note of. And when we're done with the clip, you tell me those four things to take note of. Those are the things that make up a computer. Exactly. Let me see my slide. Yes, so hope you guys, are you guys ready? Check, check.
Yes, so
Okay. So these are a group of scientists. This is what they have to say about computers. My name is Mei Ku, and I'm a designer and an inventor. So some of the things I've designed have been at Apple, and now I design products for kids to use so that they can have an easier time in school. My other jobs include DJing and dancing. Computers are everywhere. They're in people's pockets, they're in people's cars, people have them on their wrists, they might be in your backpack right now. But what makes a computer a computer? What does make a computer anyway? And how does it even work? Sorry guys, I mistakenly restarted the video. So I wanted it to understand, like, I want to get into what makes a computer a computer. Yeah, so sorry for that. Sorry for that.
yes, it's all right.
Yeah, so I wanted you to like okay, yeah. So what makes a computer a computer? Let's know. Let's know now.
You're a computer anyway. And how does it even work? Hi, I'm Nat. I was one of the original designers of the Xbox. I've been working with computers since I was maybe 7 years old, and now I work on virtual reality. As humans, we've always built tools to help us solve problems. Tools like a wheelbarrow, a hammer, or a printing press, or a tractor trailer. All of these inventions helped us with manual work. Over time, people began to wonder if a machine could be designed and built to help us with the thinking work we do, like solving equations or tracking the stars in the sky. Rather than moving or manipulating physical things like dirt and stone, these machines would need to be designed to manipulate information. As pioneers of computer science explored how to design it, they would need to take input, store information, process it, and then output the results. Now, this might sound simple, but these 4 things are common to all computers. And that's what makes a computer a computer. The earliest computers were made out of wood and metal with mechanical levers and gears. By the 20th century, though, computers started using electrical components. These early computers were really large and really slow. A computer the size of a room might take hours just to do a basic math problem.
These machines are things of gleaming, vari-colored metal and numerous flashing lights.
Computers started out as basic calculators, which was already really awesome at the time, and they were only manipulating numbers back then. But now we can use them to talk to each other, we can use them to play games, control robots, and do any crazy thing that you could probably imagine. Modern computers look nothing like those clunky old machines, but they still do these same 4 things. First, we're going to talk about input. This is my favorite because what input is the stuff that the world does or that you do that makes the computer do stuff. You can tell a computer what to do with the keyboard, you can tell them what to do with the mouse, the microphone, the camera, and now if you're wearing a computer on your wrist, it might listen to your heartbeat, or in your car, it might be listening to what the car is doing, and a touch screen can actually sense your finger and it takes that as input on what it's doing. All these different inputs give a computer information, which is then stored in memory. A computer's processor takes information from memory, it manipulates it or changes it using an algorithm, which is just a series of commands, and then it sends the processed information back to be stored in memory again. This continues until the processed information is ready to be output. How a computer outputs information depends on what the computer is designed to do. A computer display can show text, photos, videos, or interactive games, even virtual reality. The output of a computer may even include signals to control a robot. And when computers connect over the internet, the output from one computer becomes the input to another, and vice versa. The computers we use today look really different from the earliest thinking machines. And who knows what the computers of tomorrow will be like? My hope is that you get to help decide what you want the computers of tomorrow to look like. But across all computers, regardless of the different types of technology they use, they're always doing the same 4 things. They take in information, they store it as data, they process it, and then they output the results.
All right. So from this, what do you guys understand? What do you understand from the word computer? What do you understand by the term computer? I think that video actually threw a lot of light. So what have you learned from the video basically? Hope you guys enjoyed the video. Yeah, okay, I can see some can see some hands. Okay, let's hear. Let's hear. Um. Okay, Gabriel. Gabriel, let's hear. Let's hear from you. And
Okay.
Nick, and I'll get your contribution soon. Okay, sorry. Go on. Go on.
What I really learned from that video is computer deals mostly with it's it deals mostly with information, and
Good.
everything that comes out of it starts with what you put into it. So
Yes. Exactly. Exactly.
everything you see now, it began from what you put into it. So if you put in the wrong thing, what the computer is programmed to process after storing what you put in, when it is done manipulating that information, it brings it out. Meaning that in a computer, whatever we put in is what we expect to get out. We can't get something different because it has already been programmed to manipulate what you have put in already.
Good. You guys, I need to see that clap emoji for Gabriel. Clap for Gabriel. Gabriel, nice one. Um, who's going next? Who's going next? Akan, let's hear from you. What did you learn from the video? Yes,
So I learned that the computer has evolved in so many ways over the years, but it kept these four components: the inputs, the storage, the processing, and the output. So like
amazing.
if you input the wrong thing, you get the wrong product.
Good, amazing. Nice one, Akan. Please clap for Akan. And Dikan, let's hear from you. I'll soon be coming to the chat section.
So, what I learned that what makes a computer is the ability to process information, ability to receive output, sorry, to receive input, ability to give out output, and ability to store. And then my contribution is that I feel like part of it should be the ability to connect to electricity.
Electricity.
Yeah,
Okay, help us understand. Help us understand.
I should help you understand. Because because lots of devices
Okay,
that are referred to as computers connect to electricity. For example, a normal systems now they connect to electricity when we connect our chargers to them. Our phones they connect to electricity when we connect our chargers to them. For example, like I said, the VR they charge, so they also connect to electricity.
okay, okay. You are actually correct. You're actually correct. Yes, you are correct. As long as you could back up your claims, you're actually correct. Please clap for that was Andika, right? Clap for Andika. Clap for Andika. We have a lot of smart people in this class. Who else? Let's see. Tito Luwani, what do you have for us today? Tito Luwani and Isioluwa.
Okay,
What do you have
so
for us?
what I have to say, what I learned from the video is that a
Okay.
computer has four components, and no
Okay.
matter what form the computer is in, it still
Yes.
retains those four components. And those four
Emphasis on
components are, so
go on, go on, go on, go on.
okay, and
You
those
said
four,
something that surprised me, but
I
go
said
on.
I said the computer retains its components no matter the form it is. And those components are its inputs, the processing, the storage, and the output. So without if any of those components are not there, the computer will not do its function. It's not work. Even
Amazing.
down to even let's say a clock. Yes, a clock. If any of the components are not there, it's not be able to work because you have to impute the time to set it, then the processing to find out seconds and minutes and hours, then the storage is to store the time so it will be able to give you time. You get what I'm saying, sir?
Yes,
Then the
yes, yes.
output the output it gives us the time we actually want to see.
Amazing. There was something that you said that like surprised me. You mentioned that no matter the form, that's what I was looking. I was looking out for. I was looking to hear that particular phrase. No matter the form. So your computer doesn't have to be a laptop or maybe desktop. That people always think that when you say computer, what comes to your mind is laptop. You get. So no matter the form, computer can come in any form as long as it does those four functions. Yes, those four functions. Then it can be called a computer. Yes. So you want to say something else?
No.
Okay, because I think your hands are up. Your hand, your hand is up. Yes. So four things stand out when looking at a computer. One, the first thing is what, please? Let me not be the one to say it. What's the first function that stands out?
Impute,
Input, yes. The second is what?
storage,
The ability to process. Good.
Storage
The ability to process. The third is the ability to what?
process the imputed information.
Yes. The process or store. The ability to process or store the information. Yes. Good. And then the final function is what?
Output.
Output. Good. There are a lot of music people here, but I'll soon come to all of you. All these people that are not saying anything, I'll soon get to all of you. Yeah, because we need to be very interactive. We need to be very interactive. So the simple idea. Okay, so with this understanding now, aside laptops now, I want you to list out what you feel is a computer that can do all these four functions. Yes. So now start
Our
begin listing them out.
our phones,
Our phone.
smartwatches,
Good. So before when you list them, you tell me where it passes through those four functions. So if you are saying phone, you tell me what is the input, how it processes it, and then the output that it gives. So that I can really see that you understand what or why you say it's a computer. So for the phone,
um,
what's the input?
for a phone,
Yes.
something as simple as putting in your password. When you
Okay.
input your password, it is stored.
Yes.
The system, the security system has to check whether the code is the correct one. Then the output is maybe you have access to unlocking your phone because you put in the correct password. But if you put in a wrong password, if you
Yes.
put in a wrong password, you notice that the output it shows you that device is unable to unlock because of wrong password.
Good. So that means, in summary, how the phone is being able to process that password you gave it is that because the right one is actually stored somewhere, right?
Yes.
Good. Good. That's okay. We'll soon be going for a break. Who else? Who else has something to say? When you're saying they this, okay, I can see some hands. Please, people that have not spoken before, start raising your hands, so I won't call you. Tuluwani, let's hear you.
Okay. Examples of computers. We have TV. We
The
have
TV. Okay.
watches. We have phones. We have desktop computers, laptops. We have ATM. We have
Okay, yes. Hold on first. You said you first mentioned TV, right?
yes, sir.
So explain how the TV is a computer, yes, using those four functions.
Okay, let's say it's a smart TV.
Yes, a
A
smart
smart
TV.
TV collects information from the user to, like, let's say, to keep an account, to have an account. Now let's say a YouTube account. To have
Okay.
a YouTube account, which enable the user to use the account
Okay.
anytime, and the account should not, the TV in general should have the four components because it receives input from the user by using the remote. It processes it from the connection. Should I say the connection between the remote and the TV?
Okay.
processing, and the storage. I don't think
So
storage is there, but the
so I was
output
about sorry, I
visual.
was about asking. Sorry, hold on. I was about asking because you only specified smart TV. So I was about asking, how about other TVs? Won't you
Yes,
consider
other
them?
yes, they are also computers.
Okay, so you said the remote gives the input, right?
Yes,
Good. That's what I was saying. Yeah.
the remote, the
Okay.
mouse, and keyboard.
Yes. All right. Flowers.
Okay, so some examples of computers also include some of our household appliances like our washing machines and microwaves. Like,
Okay. Okay. Hold on. Hold on. Hold on. Now let's talk about the washing machine. So how does it go through those four functions?
okay, so when you give it a command by pressing the buttons like 30 minutes of washing and rinsing or something like that, that is the input. And then the computer in the washing machine is going to measure the amount of water it's going to use. It's going to look at it's going to count down how many minutes is going to be used to wash this and that, the amount of soap and the drum spinning as well. That's the storage and processing before it gives you the
Yes.
output of your clean clothes.
Wow. You guys are so interesting in this class. So you all are so interesting. Please clap for yourselves. Clap for yourselves. You guys were so attentive. Let's take from Andika. Andika.
Okay. Okay, sir. Yes, sir. Please,
Yes.
and consider what Flower said about a washing machine being a computer. I don't
Okay.
think a washing machine stores information.
It processes.
I
It
think it,
processes information.
yeah, it processes, but yeah, it does, but it does not store.
It doesn't store information.
Yeah,
Okay,
because
explain
every
how it
time you
doesn't.
turn it on, you have to. uh,
Explain how it doesn't store
Yeah, okay,
information.
okay. Well, because every time you turn it on, you have to imply your settings or to run on the settings already there. Washing machines are they're like you have to set it to the particular, like there are different settings you need to turn on for the type of clothes you're washing. So like I think it doesn't store information because store information means like you could go back to what you did in the past, but I don't think you can do that to the washing machine. I don't think it stores information.
Okay.
It's based on what's already put. So
So, Chad,
so an
do you,
example of
do you think it's correct? Wait, first, hold on. I want to see whether the class think you are correct. So, Chad, do you think it's correct? Is he right?
Not really.
Hmm? Would you say? Is he correct? I don't think Flowers agrees with you. I'm beginning to enjoy this. Flowers, you don't agree with him, right?
No, I
She said
don't
not exactly.
really
So Flowers,
agree.
let's hear from you. Why don't you think he's right?
Okay, so when we say storage, right? I think that the computer in the washing machine does store your information because when it's processing it, it has to store the information first of all and be like, okay, this is to be watched for 30 minutes, right? That is storing the
Good.
information in its motherboard before it starts turning it into an output process. It's going to store okay, did you choose to rinse and wash? Did you choose to dry? It's going to store that information to implement. So that's what it means by storing the information in the motherboard
Okay.
of the computer.
yeah, question.
You see, you see, what to
Question.
say.
This,
Someone should mute. Okay, go on, Andy
uh,
can. It's like you're not convinced.
okay. Yeah.
Then
You,
when
you
you are done,
know,
I'll tell you my mind. So go
a
on.
washing machine actually, okay, a washing machine actually has a computer, but the washing machine itself is not a computer. The computer in
Hmm.
the washing machine tells the washing machine what to do, but washing machine itself is not a computer. Because you can't tell me now that the washing machine has a motherboard. You can't. No, no. There's a computer in the washing machine. The washing machine is not a computer.
This is getting interesting. This is getting interesting. Wow.
Yeah, that is what I was referring to. I know that the
That's
washing
yeah,
machine is not a computer. I know that's what I meant by the motherboard. I meant the motherboard of the computer inside the washing machine because it has microchips and all that inside inside the washing machine. I
yes.
understand that the washing machine itself is not a computer. I'm talking about the computer inside the washing machine.
Yeah.
Okay.
Pretty much. But like you can't call a
Okay.
washing machine a computer. So you say
Oh,
washing machine or like kind of wrong. No
okay.
offense.
Now, okay, and they can. Okay, before you
Yeah.
continue, when we say something has components, does it mean that the components are separate from it, like the stuff itself? Like when we are talking about, let's say, a laptop has components inside of it. So would you say
Yeah.
those components are outside? Like, would you say they are not part of the laptop?
No. No.
Exactly.
I can't say enough at a laptop.
So you said that a washing machine has a computer inside of it,
Yeah.
right?
Yeah.
Isn't it? Doesn't that make like it's part of the washing machine, right?
Yeah.
Doesn't that make it a computer on its own?
Oh no. I don't know how to explain it, but the washing machine is not a computer. Yes, it has a computer, but it's not a computer. I don't know how to put this, but a washing machine is not a computer.
It's like my assistant has something to say. Let's hear from him. But this is getting interesting, honestly. Budi, Andikan, yes, Andikan was speaking. Budi, let's hear from my assistant. Yeah, unmute your mic, Budi. So let's hear your opinion.
Okay, and Deacon, you're saying a washing machine is not a computer because, or you're saying a washing machine has a computer, but it's not a computer. That's what you were saying, right? And
Yeah,
Deacon,
yeah. That's right.
okay. Now, what do you think a computer is for a washing machine to not be a computer?
No, it said that for device to be considered a computer, it needs to store information.
Yeah, a computer, a computer is a device that takes input, processes it, and produces output. It's not
Not
necessarily
necessarily
a laptop
laptop
or a
or a
desktop or
desktop
all
or
those things. It's just a
just a
device that
device
can
that can
take
take
input,
input,
process,
process,
and give
and give
output.
output.
So with
So with
that
that
information, you can
information,
see that what
what
this
this
girl
girl
Flower
Flower
was
was
saying
saying
makes sense that a
that a
computer,
computer,
like a
like a
washing
washing
machine, is
machine
a
is a
computer.
computer.
Because like
Because
what
like
my
what my
partner
partner
said,
said,
the
the
components
components
that
that you're
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 separating
separating
from the
from the
washing
washing
machine
machine
doesn't
doesn't
make
make
it
it
like
like
it
it
doesn't
doesn't
mean
mean
that
that
it's
it's
not
not
a
a
computer.
computer.
Those
Those
components
components
are
are
actually
actually
what
what
makes
makes
the washing machine a computer. Do you understand?
Yeah, but like how
Okay, so
do
you
like how
understand
does
that
it
a
store?
washing machine, how does it
Huh?
store? Now there are
Yeah, how
things
does it store?
called temporary and permanent storage.
Yeah,
Not everything stores something temporary. Now, like let's take the clothes that you put inside a washing machine, for example. Is it not storing the clothes? When you press something on your washing machine to, let's say, what is the information I use? Let's say you want to wash now and you forgot to add something. If you press pause now, temporary storage, it keeps it there and stores it there temporarily, not permanently. Not everything that you store in a computer has to be permanent. Do you understand?
yeah, yeah. I do.
Okay, so you get now that a washing machine items, technology can be computers. That is the thing. Technology, as long as it can process, it can take inputs, process the input, and give out outputs. It makes it a computer. Not necessarily laptops, desktops, keyboards, all those things. Do you understand?
Yeah, but like
Now, my
like
partner continues from where he stopped. If you have more questions,
yeah, there's some washing machines too that don't have computer in it. So can you call those washing machines a computer? They
well,
use they
my partner will continue from there.
okay.
Just keep asking.
Okay.
Okay, thank you so much, Favor Woody, for that contribution. So I hope you guys can understand now.
What?
Okay, you have a question. You have a question, and you can.
Yes, yes, yes. I think that's a question. There's some there's some
You know,
washing machines too that don't have computers in them. They don't have microcontrollers. They work on purely mechanical things. So could you call those washing machines a computer?
Wait, I don't get your question. Are you trying to say that there are some washing machines that don't have computer inside them?
Yeah,
Like modern washing machines that don't have computers inside?
modern. But like, not necessarily modern, there's some of them that do not have computers in them.
Wait. You are not making any sense. No, I'm not trying to downplay your question makes sense, but
Yeah, no, no.
the way you're asking it does not really. What washing machine do you think without all these things can run normally?
There's some that do run on mechanical things.
Like which one?
They work on mechanical timers.
I don't know. Do you manually operate the washing machine?
Wait, do I manually operate the washing?
Those washing machines that you're talking about, do you manually operate them?
Yes,
You manually operate washing machines.
yes.
You can't manually operate that. That means you're washing the clothes by yourself now. You can't manually operate washing machines. All washing machines that
Wait,
you're seeing now, at least in today's age, all operate electronically.
what do you mean? What do you mean manually operating the washing machine?
You are
Manually,
saying it has mechanical timers now. I'm asking
yeah,
if
it is.
you use your own hands to be turning the clothes and everything.
Oh no, no, no. I thought you meant like if you want to like press the buttons.
You're pressing buttons now. That is the input you're putting inside the washing machine. Do
Wait,
you
I don't
understand?
get. No, no, no.
Okay. You said this washing machine you're talking about, you press the buttons yourself.
Yeah,
Even in modern washing machines, before you are to do anything, you press buttons to to let the washing machine know what you want to do. That is the input. Do you understand?
yeah,
You understand now?
yeah.
Do you have any more questions?
Uh, no, no.
No. Okay.
Wow, wow. Thank you so much. Thank you so much, my partner. Wow, this you can actually agree with me that this class has been interesting so far, right?
Yeah.
I can see some people's hands still up. I want you guys to go for a break. Oh. This is already you're supposed to have a 10 20 minutes break. So before you go, just leave your questions at the chat,
So,
um,
so please, could I
the chat room. I can
say
see
something?
Christine's hand up. Okay, I'm seeing. Okay, let me just read from the chat. I'm seeing an alarm or smartwatch. Yes, yes, an alarm and a smartwatch. They are all computers. Yes. The break is 20 minutes. So yes, so we're actually behind time. It should have been about 10 minutes ago. So um and the kind of sense, sir, please, I don't get the question. Okay, you still have something to say. Okay, just hold it till when we're back from the break. Hold it till we're back from the break. Is that all right? No, I'll clarify all your questions. I know there'll be a lot of questions. It's a very it's a very um very challenging class, but we're all learning. Me self, I'm still learning, you get, so that's what we're here for. We're all here to learn, no matter your level of, you know, your level of education, or because we have a lot of age groups here, so we're all here to learn. So I'll just leave you guys for now. By um by 10:45, just get back to the call. Or you can just mute your mics and do whatever you want to do. No need leaving the call. All right. See you guys in how many minutes? 30 minutes. See you guys in 30 minutes. We'll just come and relax and then I'll start by 10:50. All right. Or you guys can go for a water break. Oh. All right, guys. The break is over. Oh. Please be coming back for those that left.
Hello, is anyone back?
Hello, everyone. I think he's having network issues, so just hold on a bit.
Okay, sorry, guys. I had a technical issue. I had a technical issue. So where were we? Where were we before we left? I said you guys should drop any questions you had on the chat. So let's go to the chat. Nobody drops question. Andy, did you just raise up your hand, or it was already raised before?
I don't think that's
Okay, you have questions. Okay, okay. Let's hear your question.
so you said that you had like it had a computer embedded in it. Now
Yeah.
laptop too has a motherboard, and whether the motherboard part of the computer. Well, so I wanted to ask you, a car, can you consider a car a computer?
Yes, yes. Yeah, of course, of course. Okay. Of
Why?
course.
Okay, why can you consider it
Okay,
a computer?
let me make it like this. Let me make it like this. All computers are technology, but not all technologies are computers. So a car is a computer. Whether it's the manual cars, the automatic car. Like you literally give it. If you're matching, do you drive a car? Are you have you driven a car before?
I don't think you're right.
There are different ways to give it inputs. Like there are different multiple ways to give the car inputs. First of all, how does it move in the first place?
How's one?
How does the car move in the first place?
Or if one well, or that is one thing.
Sorry, you're not audible enough.
A car moves, and which moves the like when you press the accelerator and the car is on the drive gear, it moves.
Good, good. To actually give it an input, which is the is it the accelerator that you actually matched? Won't you call that an input?
Yeah, I can it.
Good. Now, when you match that accelerator, yeah,
Yeah.
output.
Huh? Yeah, yeah, when you match the accelerator, it's not input, then it processes and then moves the vehicle, it's not output. So it does not so.
What is the output? What is the
And
output you get?
you can't come up with the output.
That is just a simple analogy.
Yeah,
You don't have to
but
overthink this thing.
yeah,
You have to overthink
I
this
think
thing.
yeah. For example, let's talk about uh, self-driving cars out or electronic cars that have embedded computers in them. Could you call those type of cars computers, even when they have embedded computers in them that perform all the work?
Ah, they literally have a logic running inside them. Like, I don't think you're actually driving. Yeah,
Huh?
you're even making things that I even what calling computers. Now you're making them look like as if they're not computers. They're actually computers from the big picture.
This is so
They
confusing.
have they have this is confusing.
Yeah.
If you don't understand in the chat, let me see. In the chat, if you don't understand, let's see so that I can know how to explain this thing very well to Andika. Andika, you said self-driving cars, right?
Yeah. All cars that have embedded computers in them.
Somebody's mic. I'm not getting participants. Please, if you understand, if you understand what we've been saying from the beginning, just identify with like identify with a raise of hands, like just wave. Let's know that you actually understand. Are there no reactions?
Hello.
Hello.
Hello, everyone. Sorry, I had some network issues on my end. Sorry for the break in transmission. Is there anything? Am I seeing what on this? Can you see more display? See any display on the screen?
No, sir, we can't.
Please let me know. Can you guys see my screen, please? Please let me know so I can.
Sir.
Okay, hold on.
No, sir, we can't.
How about now?
No,
Questions now. Okay, can you guys hear me now? Sorry, the network is really it's it's really a mess over here. Let me let me reshare my screen. Just give me a moment. All right. So where were we before I left?
Okay, yo, sorry for the wastage of time. My partner is having some network issues. And Deacon, you were saying something before all this started. What were you saying?
We were talking about that car, so whether a car, a computer.
Okay. Can you please repeat your question?
Oh, you said, remember when I asked you, no, you said that a microcontroller is inside a washing machine, that whether that microcontroller is a part of the washing machine itself. So you now give an instance that the motherboard of that the motherboard is inside a laptop, and that can we say that that motherboard is not part of it? I said no. So I now ask, for example, a car has lots of embedded computers. Whether the car itself can be considered a computer.
Sorry, I didn't get that last part. There's a lot of
Oh,
noise here. Can you?
okay. So I now said that a car has lots of embedded computers in it. And I now said whether you can consider a car itself as a computer.
Now, the best way to describe a car on its own is technology, not necessarily computer. If it's a, how do I explain it? Because I heard you talking about self-driving cars now. Let me use that as an example.
Yeah.
Now, the self-driving cars, you can call them both computers and technology. Now, a car on its own has a lot of computers inside it, and it as a whole, everything combined is now a computer. While using the let's use the basic and simplest definition we gave you, the input, processing, and output. Like my partner said, can you hear me?
Yeah.
Okay. Like my
Yeah.
partner said, input now, because for self-driving car, input does not necessarily mean you have to be touching things inside the car or the computer.
Yeah.
Like for the car now, the inputs could be the information is collecting about the roads, the other people on the roads, the traffic lights. I'm using your self-driving car to illustrate what
But
I'm
like,
saying.
it's not the car that gets the information. It's not in the car that gets the information.
Yeah, that's what I'm saying.
But it's in the car. No. What do you mean like the car? Do you mean like the actual
Okay.
car, like the computer in the car?
You want to call the actual car the computer?
No, the actual car is not a computer.
Hmm. Can you clarify your question?
Like I said all over again. Oh, I just
Yep.
asked since since a car has lots of embedded computers in it, whether you could call the car itself a computer. Okay. If you have a car and I take away all the embedded computers in that car, can you still call that car a computer? I think
You yourself. Let's ask you this thing. The computer, let's use the laptop now. The laptop, if you take away all the core components of the laptop and you just have the frame, can you call it a computer?
no.
Are you understanding me?
Yeah, I get
Uh-huh.
you.
Now, what makes the computer? A computer is not just the frame and everything, it's all the components inside it that can take the input, that can process it, and that can give out outputs. It's not just the car itself. Because for the car to work, you need all your engines, your embedded systems, everything. Like a computer now, if you don't have your motherboard, if you don't have your fan, your cooling fans, and all those things, it won't work. Do you get me? And they can.
I get you.
You get me? Yeah. So I understand the question now. The car itself is just it's like the frame that a car and everything combined with it is what you call a computer.
Yeah.
Not just the car itself, because the car itself is just the metal. You can't just even in a laptop when you're making a laptop, just the frame and the hard part that you're touching on. And if you remove everything inside it, you can't use it. You can't call it a computer. Do you get me?
Yes,
Okay, does that answer your question?
yes. But like so an appliance.
Huh?
So so the car is an appliance.
You mean the car itself, the frame?
Okay. You give an instance about a laptop um without all these parts, but the main purpose
Yeah.
of the laptop is just to
Hmm? What did you say?
I said the main purpose of you gave an instance about a laptop, and the main purpose of
Yes.
a laptop is to process information. But the main purpose of a car isn't to process information. The main purpose of a car is to is to um transport. It's for transportation. If you take away everything from this laptop, you can't call it a laptop because the laptop needs that to process. But if you take all the computers away from a car, you can still call that a car because it drives on fuel and it could drive and it has other mechanical parts.
Yeah, I could. What I'm saying is that without all those parts, you can't call a car a car. Just like without all these parts, you can't call a computer a computer. Oh, sorry, a laptop a laptop.
And stop that.
You're trying to you're trying to say, how do I put this? If you're saying that if you remove all those systems inside the car, you can see it's the car. If you remove your engine, even that first before everything inside that car is what makes the car run, is it not?
Yeah.
Take the laptop now, your motherboard, your electrical, everything inside the computer now. If without it, will the computer work?
If you take away all this that if you take away all that, you can't call it a computer. It becomes a computer frame. Now, because the computer
Yeah,
needs
and
to.
if you take away all the engines, the brake pad, the brake fluid, everything about
No,
it,
I didn't say no, no,
would
no.
the, would the car move?
I didn't say engine. I said computer. If
A
you have an
computer does
engine,
not have to be okay. Let's not okay. You can understand that not all computers are electrical. Do you understand?
please, could you give an example?
This car that you're talking about now. Or let's say, what example will I use now? Because the question you're asking,
Hello, everyone.
Hello, sir. Hello, sir.
Yes. I don't know. We're going back and forth on one particular thing.
Everyone, I'm sorry. I'm just so curious.
No need to apologize. No need to apologize. We're all here to learn. We're all here to learn. I can see that Akan, you are the new host. Please co-host me, I beg. Please co-host me. Sorry. Yes. Thank you.
It's alright.
Um. Yeah. So, what do you see on the screen now? Don't worry. I think I will get back to you. Don't worry. You can come for a private class.
Okay, please.
Yeah.
Yeah,
You can come. You can come for a private class. We must get to the bottom of this.
Andy can. Let me just
Yes,
that question you asked about all those computers that aren't electrical stuff that use like the washing machine we're talking about now, the mechanical section.
Yeah.
I told you it's still a computer. Not it doesn't have to be electrical for it to be. That's why my partner mentioned that all computers are technologies, but not all technologies are computers. You understand? Like the car now, because Andy, can you hear me?
Yeah, I can hear it. Loud and clear. I want to.
Now, let me put it this way, because you're talking about the processing part. If you remove all the electrical components, right?
Yeah.
Now, computers don't need electricity to process information. If you if your car is moving and you press the brake, what you're pressing, what do you think? You think the car just stops on its own? All
No,
that
there's some
once you press the brake, information
mechanical.
reaches it reaches all the mechanical parts and the car stops. Do you understand?
Yes.
And they can.
Yes, I can hear. I can. I
Okay.
can hear you.
So
And they
they
can
can
listen.
listen. It's okay. Computers don't need to use electricity to process information. That's what I'm telling you. As long as your device can take inputs, process it, and give out output using mechanical movements, liquids, all those things. It doesn't need to be like mechanical levers now.
Yeah.
You can't say that because it doesn't have any electricity used inside it. You can't call it a computer. A computer needs to take input, process the input, and give out output. Do you understand?
That's no. Yes.
Okay. It seems you're really interested about these computers and this their input. So if you, I don't, we'll communicate how to later around the end of the class. We'll get back to that and tell you what you need to know. Is that all right?
So
So
we
if
are
you can't speak, signify.
I can't
And
hear
is that all
you.
right?
They're kind of breaking.
Okay. Sorry. What I was trying to say is that we can't spend the whole day on this. We can't spend the whole day on this your or if this is a computer or this is not a computer. So what you're going to do, you're going to put all your questions in chat so that we can because we are behind schedule. Do you understand? If you can't speak, signify.
all right. We are going back and forth on one particular thing. What I would demand of you, Andika, is it Andika? Sorry. Just after this call, you can always reach out to Buddy. He's on the WhatsApp group. Hope you all are on the WhatsApp group. Hope you all are on the
Yeah,
WhatsApp group.
my
So
mom's there. I don't have WhatsApp.
yeah, so just reach out to him. He's there. You get any problem you have, any questions you have, we're always ready to answer you. There are other tutors that are here for you. We'll answer all your questions. It's just that right now we are running out of time and there's a whole lot to cover.
Yeah. Yeah.
Is
I
that
understand.
okay?
Yeah, thank you.
Hope you guys are on the call, because this one is just one person that is talking. Please, if you are still on the call, let me know that you are still on the call. Just drop, just
Excuse
wave
me.
or
Is a
okay,
power
who's
bank
that?
is a power bank to a
Who's
computer?
please, please, next time if you want to say something, yeah, if you want to say something, you raise your hands first and then I'll give it a why I was actually allowing Andikan to say something because he was actually we're trying to make him understand. That's why. So
Okay,
if next time if you want to say something, don't just cut me.
I'm
Do you
sorry.
understand?
Yes.
Yes. So what's your question? Please, this is the final question for now, so that we can actually look into other things. What's your question?
I said is a power bank to a computer.
I won't really call a power bank a computer. I will not really call power bank a computer because it doesn't actually perform the functions we actually discussed. You get it's just a power bank is just the main purpose of a power bank is just for storage. Like it stores it more like stores it
Ba.
supplies electrical energy basically. So you will not call
A power bank a computer.
yes, yes. You can call it a technology, but it's not a computer. It's not a
Oh,
computer. Yeah. So guys, I'm seeing some comments. When are we going to see you? You will code, don't worry. We'll all get to that. There is a whole lot of package for you guys on these 5 weeks. We get it. For now, we just have to get the ground knowledge. Just have to get the ground knowledge. So I'm going to be displaying something on my screen now. Is that okay by you guys? Please wave. We'll make use of this wave so that I can know you're active on the call. Remember, it was part of the rules that you need to show activeness. You need to show activeness. Don't be this. Don't be this student that just come around and you just sit down, not say anything. I'm seeing a lot of mute people here. All Rikechi, Christine, Soma, like all these people be giving out contributions so that I can know that you actually because after this now I'll still give an assignment. Very soon we'll be moving into Teams. We'll be using Teams. Who knows about Microsoft Teams? Or who has used Microsoft Teams here before? So for those that don't know, that's what we're using. But for now, we'll be doing our assignments there. Okay, so I think we need to establish that fact that, or we've actually been able to understand what a computer is. Yeah, yeah. So I have one question for you guys. Can you see my screen? Okay, the answer is there already. I forgot to remove the answers. So it says, how does a face unlock work? You're supposed to actually be the ones to tell me answers, but I actually it looks like it looks like I actually just blew my cover. But it's all good. Um yeah. So let's go to the next. So I'll just give a few. Okay, let's take for instance a robot. Yeah, a robot. Who can tell me how a robot, like, we all know that a robot is a computer now. So a robot is a computer, or it's a combination of computers, right? So who can explain to me how it's actually is a computer, like using the four principles we listed out before, the four functions? Yeah, like it doesn't have to be one particular, like, robots perform different functions for different purposes. Yeah, so like a simple mechanical arm robot. Just give me an instance. I'll still show you a simple clip so you can let me know. Please, I need all your activeness. Who drew a line on my screen? Please don't draw my screen, please. Please don't draw my screen. Uh, don't draw my screen, please. So I don't get angry. Don't be mute, guys. Don't be mute. Okay, it's like you don't
So
understand. Let me just
a
play this.
robot.
Let me just play this clip. Let me just play this clip. Don't worry. Okay, I can see some hands. Sorry. If you hand that up, okay, I can.
So a robot. A robot is a combination of different computers in which
Exactly.
the
That's what I was
user
looking for too.
has
Yeah.
to input a particular code so the robot can do according to that code because technology cannot think for itself. You have to it has to obey the commandments of the user.
This is commandment. Okay. Andy, can you want to say something? Please. Okay. Don't ask questions yet. Just
Just
hope it's
a
not a
question.
question. No.
Oh, no, no question.
Yeah. Okay. Just you say what you want to say.
Everybody's just hardware from getting what you do from a bunch of tools.
Sorry, I'm not. You're not audible enough.
Uh, a robot is just simply a hardware, just getting what to do from software or a bunch of codes that are around. What do you mean
Okay.
to make
Good. Good. That's what I want to hear. So you're all correct. So from this short clip, I'll play this short clip now. You tell me what you noticed from the video. Please, whoever drew this red line should remove it. Whoever drew this red line should remove it. Don't be drawing on my screen. Uh, okay. Oh, sorry, I went back. Okay. So who saw what just happened? Do I need to replay the video?
Yes, we play it.
Okay. Yeah, so what just happened? Or I should play again one more time. Should I replay again? So what did you notice from the video? Let me play it one more time. Okay. That's a very short sample clip. So what did you notice? No, you don't really necessarily have to tell me what happened, or just tell me what you've seen or what you've noticed from the video.
Oh,
Please, before you speak, raise your hand. Okay, Andy can, yeah.
He just picked up the block
By
and
next,
dropped it.
sorry, hold on. By next class, these people that are active today will give room for people that are not active. All these people under this Rikechi, Christine, Isoma, who else?
Autobom's iPad.
Damilola, Autobounce iPad, very important. I would like to get. Please don't be mute next time, please. Okay, go on, Andikan.
The robot just picked up the block and put it in the box.
No, you're not audible enough. Sorry. Repeat. Please
Oh,
repeat.
the robot just picked up the block and placed it in the blue bucket.
Okay, okay.
But like,
Yeah.
I feel like the sensors to it.
Yes. Well, we're getting to that, Shaba. That's what yeah. Felicitas, how about you?
Okay. I noticed that robots too are multifunctional machine that helps us to do
Hmm,
work.
that's big grammar. That's big grammar. What class are you?
Yes, three.
Just three. And you know multifunctional. Hmm? Yeah, okay, sure. Yeah, you're actually right. It's multifunctional. A robot can have different functions. There are some robots that have few functions. There's some robots that have just one function. You get. Yes, some can have multiple functions. So yeah, very correct. Isioma is the parent. Oh, okay. Oh. All right. Okay, I understand. Isioma is the parent. So the okay, we'll soon get to the names. We'll soon get to the names. Is there any more? Okay, Christine, finally. Let's hear from you, Christine. Christine.
What I saw on the video was a robot carrying a cube and putting inside a bucket.
Good. Nice one. That was a very beautiful observation, Christine. Yeah, very correct. Akan, you have something to say?
Yeah. In this video, we see a mechanical arm carrying a cube and putting it directly inside
The
the bucket
mechanical.
without any floor.
Okay. You guys, everybody's actually correct. Yeah, everybody's correct. But there's one question I want to ask. How did how did the mechanical arm, or let's say the robot arm, actually know where the box was or where the cube was? How was it able to see, or how did you get that input? That's what I want to know now. Oh, I can see a lot of hands. Let's hear from Flowers. She was the first.
Okay, so like the mechanical arm does not see in a real sense, right? It has
Okay.
sensory,
Okay.
it has sensors that like
Hmm.
that
Hmm.
radiation and stuff like that. To see that it's the sensory will tell you that okay, there's an object here. So that's how sometimes when you see
Yes.
these robots that move, they can't actually see really. They just sense that, okay, there's an object here. They should redirect their focus. And that's how it
Okay.
operates alongside codes that
Okay.
it's given.
Okay. Amazing. Amazing contribution. Let's hear from others. Otobong's iPad, finally. Let's hear from Otto. Sorry, that's not your name. I'm sure that's not your name. Please, when you open your mic, just let me know your actual name. Otobong.
The robot has sensors in like built inside it. That's why it's able to carry the cube and put in the box.
Okay. Part of it. You are actually still correct in some way. You're correct too. I saw somebody raised a hand and then took it down. So you're all correct, actually. Nobody's wrong. Yeah. They actually sensors. Sensors for every robot, for it to actually receive an input, there must be a sensor. There must be that sensing mechanism. Yeah. So a final question from this video. How did the robot know where to put the cube? How did the robot know where to? Okay, Autobahn. Okay, you are Akemini. Okay, okay, okay. That's noted. That's noted. I'll need to know all your names. Sorry, Isyoma's mom. What's her name? Sorry, so I don't keep calling Isyoma. Yeah, so I'm waiting for your contributions. So how did the mechanical arm know where to put? Okay, Rikechi. But there's another Rikechi in this call. Okay. So how did the robot's arm know where exactly to? Because very soon we'll be going into, we'll actually have to do some little small coding. So we need to actually understand these concepts before we even go into anything bigger. Okay, Christine. Christine? Is it Christine? Yeah. Please, let's hear. How did the mechanical arm know where to keep the cube? Or how to? And
Medical
was so
and
perfect.
the sensor to sense the cube, then put it inside the bucket.
He sends the cube. I mean, how did he know where the bucket was? Or how did he know it was supposed to put it inside the bucket? No idea. Um, okay, so since nobody wants to, since there's no idea. So basically, how there are three things involved in this video, which I'll list now. And these three things are what make up the concept of a robot. You get? So these three things, I'll just list them now. There are three words: sense, think, and act. So if there's a way you can get that down. Sen- Is somebody saying anything? Okay, okay, Andika, your hand is up. Okay.
You said, how does the arm know where to put the cube in the bucket? I feel like
Yeah, I was asking the question. I don't know what he was saying anything.
I feel like the code that was um that was written. It wasn't really meant for like to notice lots of objects. I feel like probably the code said that once it notices an object, that it should move a little distance forward and then drop the cube.
Okay.
Yeah.
Okay. So you're saying that it was from the code, like it was what was written on the code, on the
Yeah.
code
And
base,
the
right?
sensor. Yeah.
Okay.
Code and sensor.
Okay. You're right. You're correct. Christine, you have what to add?
Yeah.
Okay, say add. Let's say your contribution. Oh, I can. Please, can we appoint prefects for this? Prefects. Okay. Okay. I think we'll get back to that. We'll get back to that. That will be right. That will be needed, Sha. That will be needed. Yeah. That will be gotten back to. Let me just move forward. Christine, you still have what to say? You have what to add? Okay. In the absence of that, so as I was saying, well, when we are looking into the term robotics, yeah, three things come into play: sense, think, and act. So a robot system needs information about its environment. You get example, like it needs, like for example, like we all said initially, sensors, right? So it needs to sense things. It needs to sense variables, or what I call process variables, but that may be too complex for you guys. So we need examples like, let's say, distance. It needs to sense like light, temperature, movement, variables like that. Yeah, so without that ability, we can't actually move to the next step, which is the thinking phase. So it has to be able to sense, first of all, then think. So it senses first, then thinks. So from that video now, you saw that it actually it didn't just have to like take that cube. There was already the sense phase where he actually had to um maybe I don't know the kind of sensors that were used for that particular mechanical arm. Maybe it was a color sensor, maybe it used closeness, proximity. So, but like there should be that sensing phase, yeah. So it collects the information. That is the inputs that it used to process, to think, to process. So the processing phase now is the thinking phase. So how does it think? It doesn't just think. It's not a human being. It doesn't have that ability. It doesn't have a brain. The brain, the word thinking is actually the codes, the instructions we give to that robot or to that, let's say, software. Let's leave the robots or software, for instance. You get, so first of all, I said it has to actually sense, then think. So the thinking is the processing of the information it gets or the input it gets according to instructions. So those instructions are the set of codes that are written, the code base that actually runs in the processor of whatsoever um, computers or robots or technology or softwares, basically. Yeah, so I'm using the word think here as a simple way of describing processing or decision making. So that thinking phase is more like a decision making phase. based on the set of codes that are written or that are running on that particular computer or robot. Yeah. And then there is now the final phase, which is the act phase or the action phase. So the system now produces an action after it senses or it takes the inputs, it processes it, which is the thinking phase, then it acts, which is more like the outputs. Yes. So for example, motor movements or arm rotation, like how you just saw now, the way the arm rotated, that is the action. It took the cube, he moved, he rotated, and then he dropped it in the bucket. So how did he know where to drop it? It's under the thinking phase. There were sets of code, like Adika mentioned, that there are sets of codes running at the background. Yet so it knew, maybe that was how it was programmed, basically. Or maybe you can have like lights turning on or the buzzer sound. So those are the three components. These are what makes up robots. It's also part. It's just the way computers are. It takes inputs, does the processing, and then gives out an output. Same thing here. It's the same thing applicable here. The sensors are the input phase. Is the input phase. Yeah. So it can't work without a sensor. Then we have the thinking phase, where it actually processes the information that it has received from the sensor, and then we have the action phase. So hope you guys understand. Hope you understand. Hope you understand. Check, check. So that video was like a visual representation of a robotic action. The sensors provide information and instructions, and then this thing. So in a real world sense, you cannot say sense, think, and act. You have what they call sensors. The thinking is the controller, and then the act space is the actuator. You get, so these are what you look out for if for those that because at yesterday's orientation we had a lot of people that were interested in robotics. Yeah, so before you even think of moving into robotics, you have to get this background, I mean this foundation. These are the foundation. This is where you build upon. This is the knowledge base that you need to get before actually moving into. So you know that three things three things matter: the sensors, the sensing phase, the thinking phase, which is also known as the controller phase, where you have the codes, the everything that runs the processing phase. Then we have the actuator. How should it move? Where should it move? You get, where should it move? I think the most simple form of this concept now is the mechanical arm. That's why I had to use the mechanical arm as an example. There are other more complex um, examples that could be used. Hope you understand. So because that is what will build your. I want you to really understand this concept. I want you to really understand this concept because that
Yes.
is you need it. You need it for your assignments that will be given because there'll be an assignment given. Yeah. Okay. Let me get to the comments. What did you say about the robot? That has to. You Felicitas, you didn't get the. Do you understand now, or I still need to explain? Okay, Andy, can you hand this up? But before that, Felicitas, do you understand now?
Yes, I do.
Okay. So any question before I proceed? Let me check you there. Okay, no questions. That means you understand. So if you understand, let me see thumbs up so that I can proceed. Let me see your thumbs up. Oh. Let me see your thumbs up. Only 7 people. Only 7 people. Okay. Yeah, so we'll soon be closing. We'll be closing in like our classes at from 9:30 to 12. So like the next 20 minutes will be done. So I'll just quickly brush up and then you'll have your assignments. So okay. So let me see if you actually understand for those that claim to understand. So imagine a robot is moving around a room and then suddenly detects a wall. What is the sensor? What's the sensor use? How did it sense the wall? It's sudden. Maybe it was walking about. He just noticed a robot moving, and then when he got to a wall or a distance, it actually just stopped. So how was that possible? And they can.
So like it has all things called ultrasonic sensors, in which sensors send waves, and then if the waves don't come back, they know that there's if they send wave and the waves actually do come back, they know that an object they they follow their line of code.
Okay. Okay. So you're saying it works with waves, right?
Yeah, ultrasonic waves.
Ultrasonic waves. Have you built a robot before?
Yeah.
It seems we have a lot of advanced tech people. Okay. Rikechi said he uses ultrasonic sensors. Okay, which has to do with waves, right? Do we all agree with that?
Yes, sir.
Yes.
Okay, so what is the thinking phase? So we're done with the sensing part of it. So as you're saying, the robot was walking around the room and then it suddenly detects a wall. What's the thinking phase in that race, in that analogy? Okay, I can.
For me, I don't just think that the computer thinks for itself. So like I think the code that was assigned to it was the one that was controlling it.
Okay.
So I think it knows what to
So what
do.
kind of what kind of code was assigned to it?
Like it depends on what the programmer wants it to do. Like pick up the cube, put the cube on the floor, arrange the cube in a particular area.
Okay.
Yeah.
Okay, so you're saying that it actually depends on what was the code base that was written, right? So
Yes,
that's the
sir.
processing phase. So how about the
Yes,
action?
sir. The action is when the robot actually performs the given task.
Okay. Okay, so let me give another example. How about what know the automatic street lights, right? Whereby you are walking and then maybe it's dark and then maybe when you pass it, do we have that in our streets? Have
Oh
we
yeah, yes,
interacted with that before? If you have interacted,
yes, sir.
let me see you wave. It's only Akan that has interacted with it. Whereby you see this street light, maybe in the night time, you just below it and then automatically it actually turned on.
Yeah.
So what kind of cell was this there?
I think it was sensors, like the sensors they had.
Yeah, yeah. What kind of sensors did you think was used?
Light intensity sensors.
Lights, right? Who else?
Yes.
Who else? Um, Felicitas, what do you think?
I'm okay with that.
Yeah, okay with that. Okay, Rikechi. Rikichi doesn't have. Um, Toluwani, Toluwani, and Ishioluwa. Yeah.
Yes, sir.
What do you think?
Yes, I'm okay with that.
Yeah, okay with that. So we all agree.
Yes, sir.
Flowers, how about you? Flowers, how about you?
Yeah, I agree.
You agree, right? Yes. So that means we all agree. That means I can comfortably give you an assignment on it.
Yes, sir.
Yeah.
Yes,
Yes,
Yes.
sir.
no
Are
problem.
you afraid? Are you
No,
afraid?
not really, sir.
Okay. So I'll still I'll still drop it on the WhatsApp group. Yeah. So I want you to design. Okay, there are two assignments. This one, the first assignment is considering the first phase of the class that we actually had. Where is the so that I can see that you all understood that first phase. It's a research assignment. So where is it?
He said, so I research.
Yeah, yeah, you do a
Hey.
research for me. Okay, yeah. So your first assignments, research on the difference between or research on what makes okay, so research on what makes a technology a computer.
Like say we should
Yeah,
research on
on what makes a technology a computer. I mean,
what
on what makes I want
a
what is a
technology
simpler way to
computer.
say it? Yes, or the difference between computers and technology.
Okay. Um,
Yes.
but sir,
Hope you
those
got
are
that
two
one.
things. Those are two different things.
And like just tell me just research on computers and technology. Let's know. Let's know what you have.
Okay, I should make a research on computers and technology. So please, are we going to present
Yes.
it?
Yeah, you submit it on Teams. I'll no, okay. Yes, you present it. You present it on our next class. But from tomorrow, I will start using Teams.
Okay,
Tomorrow
sir.
morning, I will guide you guys
I'm
on
going to switch
opening
it to Teams.
a Teams account.
Okay,
Not
sir.
not Teams as per like splitting into teams. Like Microsoft
Microsoft.
Teams is an app. Sorry, it's a
Oh,
software, it's a website.
wow.
Yeah, so I'll drop an explanation
Yeah.
on the group on so you guys can create an account. So that's where all your projects will
Okay.
be submitted, your assignments and everything. Yes. So I hope you guys
What
have
about
gotten that
today's
one.
assignment? Also do it there.
As for today's own, you may do it there. I'll just drop a guide on how to create it. But just some for today's one, I'll just let's just yes, let's just leave today's one for now. We'll start that tomorrow. For today's one, we'll just discuss it here on the call by tomorrow.
Okay, so
Yes. Or but when we are done, just keep it with you. Then when we actually open the Teams group, you just submit it alongside the ones we'll give tomorrow. Do you understand?
yes, sir.
Sir, please, what's the second assignment?
The second assignment. Okay, yes, I'm getting to that. So your second assignment is that I want you to design something that solves a real problem. It could be anything.
In one,
So it is
one
going.
after.
So it's in five phases. It's going to be like what would you call it? First of all, it's a smart device. This particular one is going to no, you will not
Are we
using
going
code.
to?
Sorry, not using code. You won't code it. Don't worry, you won't code it. I just want to get your ideas because that's what you might work with on your final tech fair day. Not just no need to shout Jesus Christ. I'm seeing Felicita shouting Jesus Christ. No need to no need to shout Jesus Christ. I just want your ideas. You know?
Yes, sir.
Yeah, so I just want you to think big, you know. Just tell me.
And
So
which
what you do for
problem
me is
can we
that
solve?
So the
any
first
problem,
assignment, we should
any
conduct a
problem.
research on computer
It
and
could be something
research.
that is already existing. Yes. That's your first
Yeah, second
assignment.
assignment we should
Yes, design something
design
that solves the real problem.
something that solves the problem.
Yes. So when you come tomorrow, you explain your. It could be a robot. It could be anything. Just so you design it, and then the first thing you give me is the name, what it's called. Second thing you give me is the problem it's solving. You get. It could be maybe to help clean up, you know, or to help solve one or two tasks. Then the third question, the third thing I'm looking out for is the inputs. What does it sense or what does it receive? You get what sensors are you using? The fourth one is the processor. What's the processing phase, which is or the thinking phase? What decision is it making? You understand? And then the fifth thing I'm looking out for is the outputs. What does it do? Hope you understand. Hope you've gotten the question.
Yes,
Yes, sir.
sir. Also, can you repeat it?
Okay, let me type the question so that for those that didn't get it, you just screenshot the question.
Thank you, sir.
Oh, I'll still drop it. No, I'll drop it on the WhatsApp group.
Okay.
I'll drop it on the WhatsApp group. Yes. But that is just what I needed to do for me tomorrow. So
Yes,
we'll
sir.
discuss it in the morning before we move to what we have for tomorrow.
Okay, sir.
Yes. So for example, now this is what I want to see tomorrow. For example, this is for the second one. So you can maybe discuss it like example like a smart bin whereby let's say I want to solve a simple problem. Dustbins can become full without anyone noticing. You get so the problem is the dustbin overflows, that kind of thing. You get so the input what we're looking out for is like a sensor, a distance sensor or an ultrasonic sensor that detects how full the dustbin is. Yes, then the process is that maybe when the bin gets to a certain level, you should turn on an indicator, or maybe you should turn on a light so that we can know that the dustbin is full. Those are the kind of ideas I'm looking out for. Felicitas, you have a question? So have you seen how it's solving a real problem?
Yes.
Yes,
Sir,
sir.
excuse me. Sir, when are we
Okay.
submitting it?
Tomorrow.
Tomorrow you have all throughout this today, afternoon, evening. You present it tomorrow for us to hear. You present it for us tomorrow. And then just keep it one side. So what you do, you not write it on book, oh, you not write it on paper. Just you can write it on paper, but when you're submitting it on Teams, you have to type it. You have to type
Hey,
it and submit it.
can we do it on
Yes.
MS Word? Then we can now copy it
Yes, on
from.
MS Word. I'll direct you on how to submit it on Teams tomorrow. But for tomorrow,
Okay,
when
sir.
you're submitting it to us, just tell us. You use your mouth to tell us what you actually have on paper because we may not be able to see. Or maybe you can turn on your camera. For those that can actually turn on their camera, you just open up and tell us what you have for us. So I think that's all for today. Anything else to add? Um, anything else to add? So what have you learned today? Let me know. Let me see if you will actually. Hope you enjoyed today's class, though.
Yes, sir.
I promise that
Yes, sir.
coming classes
Yes,
will be
sir.
more interesting and more engaging. We have a lot to actually
Yes,
uncover.
sir.
We'll look into other. We're going to look. It's going to be very fun. I promise you. It's going to be very fun. We'll look into web developments. We'll look into AI. We'll look into cyber security. So just sit back. So let me see that you enjoy. Let's just type what you or just tell us. Everybody must tell us something. You must tell us what you actually got from today's class. So one thing you learned, just one thing you learned from today's class. Let's know. What's that thing that you can comfortably say that, okay, yes, this was what I learned today? Or if your mommy asks you or your dad asks you, what did you learn today? What can you tell her? So I need your hands though, and this one is just one person that is raising up. So I need your hands up. If you can't raise your hand, just drop it on the chat section. Okay, so flowers. Let's hear. What did you learn today?
Okay, what I majorly took from today's class is that the misconception of a computer just being your laptop is incorrect. It's
Yes.
literally anything
Yes.
at all. Anything at all that
Yes. Yes. I learned that too. I learned that too in this class. Amazing. Amazing. Um, who else? Okay, flowers. That's flowers I just spoke now. Okay, flowers, you're saying something. Is it my network? Flowers, I think you have connection issues. I think you have connection issues. Someone's hand is up. I can see a lot of people came very late. So this Damian up front at the home front. Please let's know what you learned to. I'm not seeing any comments except I can see I learned that the computer does for me. Yes. Yes, yes, yes. We all learned that. Nice one, I can.
I think so.
And they can. Okay, and they can you learn the same thing too, right?
Yeah, I want to say that.
Okay. Tito Luwani.
Yes, sir. I learned that the computer must perform four major components, which is the input, processing, output, and storage. And it
Okay.
cannot be a computer if one of them is not there. And I also learned that a computer must not be in the form of a desktop or a laptop or a phone. It can be
Yes. So who? Yes, yes, yes,
it
yes,
can be in form of a car, in form of a television, anything at all that performs those four
yes.
processes. Four components.
Exactly. Exactly. Nice one. Nice one. Who was that? Are you siblings? Tito Luwani, I said Tito.
Yes, sir.
Toluwani and Isioluwa. They are
Yes,
siblings,
sir.
right?
Yes, sir.
Okay. Rikishi, I can see he said I learned that a computer has four features. Oh, yes, beautiful. I learned that the computer takes input processes. Wow, amazing. Allow, okay. I understood the process of computer. Okay, amazing. I learned that. Okay, okay. So you guys learned a lot. That's amazing. Clap for yourselves, please. So it shows that I wasn't sitting down or I wasn't wasting my time boring you guys, right? So today's class was actually amazing. It was interesting. Also, I have an announcement to make too. So I noticed that some people actually came late and missed out on all the fun. Yes. So a recorded, a recorded, a recorded. Okay, I'm seeing new messages. Okay, okay, yes. Dami also learned something too. Okay. Dami, were you here from the beginning? Were you here from when we started?
Who just
I
came now
doubt.
started copying me?
Uh, I doubt. So, but next time, tomorrow, please try and come early. Yes, and also, please, very important announcement to make. By next class, because I'm seeing that most of the names here are actually your parents' names. So if there's a way you can actually change the names, the display names here, yeah, the display names here to your actual names. So don't call your parents' name, please. Yes, that's a very important announcement I wanted making. So just after this call, just try and change your Zoom display name to the name or like to your actual name. Or for parents that are here, please change it to your one's name. Thank you. And then a recorded version of this call. If you notice when you join this call, you heard this call is being recorded. Yeah. So a recorded version of this call is actually available on YouTube. Okay, that's fine, Dami. So a recorded version of this call is available on YouTube. So I'll drop the link for those that didn't join from the beginning. You can always rewatch the videos. All right. So thank you for your time. Thank you for your time. See you guys tomorrow, same time, 9:30. Please don't be late. There'll be announcements. Yeah.
So,
There'll be announcements. Bye. See you tomorrow. Take care of yourselves.
Okay, sir.
All right. Yes, let me end the call. Okay.